Okay, everybody, so this is a video about how to do the one-way ANOVA in Excel. If you're using SPSS, this video is not for you. Go look at the SPSS videos that are posted onto Canvas. This is just for the people that are using Excel. Okay, so let me share my screen with you, and I have some data already entered into Excel, into a spreadsheet. It looks like this. And for this example, just to kind of set it up, the IV and DV and all of that, let's say that we're studying something like, let me get this banner out of the way, hold on a sec. We're studying age, so that would be our IV, or in ANOVA, we call that a factor, and it's got multiple levels for age. So if age is the IV or the factor, we've got 3 different groups here, and you want to do an ANOVA when you've got at least 2 groups, but typically when you have more than 2 and you're looking for differences between the averages, you would run this one-way ANOVA if you have one factor or one independent variable. So in this case, the independent variable or the factor is age, and we got 3 groups. We got group A, group B, group C. And group A is 4-year-olds, group B is 8-year-olds, and group C is 14-year-olds. I was reading this journal article. It was kind of interesting. It was about creativity for children, and it didn't have to do with, it wasn't like artistic creativity, it was problem solving creativity. And what these researchers found, that children were more creative in their problem solving, well, in stages. Like it changed depending on their age. Like typically they were better before they started some form of like formal education, and then they kind of became less creative in their problem solving. And then when they became older again, older children, then they became more creative in their problem solving again. And I thought that's an interesting phenomenon. I can create a little ANOVA example around that. So we're going to compare these 4-year-olds and 8-year-olds and 14-year-olds to see if there are any differences anywhere. So remember, with the ANOVA, our hypothesis here is really just that there will be a difference between these 3 groups somewhere. There could be just one difference. Maybe it's just the 4-year-olds that are different somehow, or maybe it's that there's differences across all 3 groups. But we'll just take any difference for now. So any difference will do. And then the numbers here that I have associated here with this example, this data, these are the creativity scores. So let's assume that a higher score means a higher higher creativity, and lower scores is less creativity. All right, so in Excel, what I want to do here first is I like to look at the descriptive statistics for each group. So in particular, I want to get the mean and the standard deviation for all 3 groups, but I'm just going to go ahead and gather kind of all that descriptive information. So the way I'm going to do that is I'm going to go over here to data, the top of my toolbar, and over to data analysis. And I'm going to select descriptive statistics. And I'm going to do this 3 times, 1 time for each group. I think you could do it all 3 at once, but I'm going to do it 1 time, 3 times, once for each group, so you can see what that looks like. All right, so you hit OK. And now you want to tell Excel which data to include for your descriptive analysis. So where it says input range, always just click within that box, input range. And I want to get group A first. So I'm going to highlight group A. I even grabbed the label. It says group A 4-year-old. That's okay. Just grab the whole thing. And then just to kind of go over this part here, it says group by. Are we doing this by columns or by rows? Well, this information is in columns. So make sure columns is selected. And then if you included the label like I did, make sure you click this box, labels in first row. If you don't want to include that label, then make sure you unclick this. But I like to put it there because it'll take the label with you when it does the output, right? So, all right, label in the first row. Now the output range, this is where you tell Excel where you want Excel to present the results from this test. Okay, so I'm going to do this. I'm just going to put it over here. Let's just put it over here to the side. So we got group A. If I click right there in this cell, that's where it's going to put all the descriptive information for group A for these 4-year-olds. All right, so we got the output range selected. And summary statistics, all looks pretty good. So I'm going to hit OK, and it's going to give us a bunch of information here. All right, so here we go. Here is the info for, I'm going to do this a little bit just so it's easier to read. I'm going to stretch out these cells. All right, so we've got the mean, we've got the standard deviation, we've got n, we've got some basic descriptive stats for our 4-year-olds. I'm going to do this for these guys. We can color code this because I'm fancy. And let's do that. Okay, so we know that's for my blue group there, group A, my 4-year-olds. And the things I just wanted to kind of point out here that we're looking at, the mean of 7.6, and we can see the standard deviation too if you want to check that out. There's the standard deviation, and the standard error is there as well. Okay, so now let's go back to data, and let's get the descriptive stats for the other two groups as well. So now I'm going to grab descriptive stats again, and this time just click an input range, and I'm going to select group B, which are my 8-year-olds. So we got them. I'm going to select an output range where I want the information to go. I like it right here. So I'm going to hit OK. There we go. There's my group B info. Let's stretch it out a little bit so I can read it. And I'm going to color this one as well. So they used kind of this orangish color. Let's do that again. There we go. Okay, so there's my group B. And again, you can see the average there. Oops, average is, come on. It's not letting me draw for some reason. Well, there we go. Okay, average is 4.6. You can see the standard deviation here as well. All right, one more time. Let's do group C now. So back to data, and then data analysis and descriptive stats. Okay, and go to input range, and we're going to highlight third group. There we are. And then an output range, we're going to select the cell where I want this information to go. Right, how about right there, and hit OK. Okay, so here's group 3. For consistency, I feel like I have to make them green now. There we are. So here's my third group. Stretch this out so I can read it a little better. And there we go. We can see we have an app here. It'll let me. No, I don't know why it's not letting me draw. Let's try that again. Yeah, okay, now it's letting me. I don't know why I didn't do that. All right, so we have an average of 7.1. We got a standard deviation down here. All right, so we're doing this ANOVA really to figure out if there is a difference between these averages of 7.6, 4.6, and 7.1. So if we're just guessing here, since the standard deviations are pretty small, I'm guessing that this 4.6 is going to differ for group B. I think that's going to be smaller than the other two groups. Just eyeballing it, that's my guess. That's my personal hypothesis there. But 7.1, 7.6, probably not different from each other, probably not cutting it. But let's find out, right? We don't want to just rely on my intuition. So let's look at running the actual ANOVA itself. Okay, so now we're going to go to data again, and then to data analysis. And in this case, we want to find ANOVA single factor. Remember, factor is another name for the independent variable. And we only have one independent variable, which is age. And we have 3 levels of age, but we only have one independent variable. Okay, or one factor. Now, I want to get, whoops, hold on a second. Cancel this, get a better look at my screen. There we go. Let's try that again. Data analysis, one-way ANOVA, single factor. There we go. So I'm going to click in my input range, and I want to select into these 3 columns here, A, B, and C. Just highlight the whole thing, and then make sure that labels in first row is selected because we have our labels here. And now the output range, we're going to select where we want the results to go. And I'm just going to put them down here below the table so they're easy to see. So hit OK. And there we go. Here is our summary table. A little bigger there. There we are. So we've got our kind of summary descriptive stats here for each group. Our N is 10 for each level. For 4-year-olds, 8-year-olds, and 14-year-olds, just 10 of each. The sum of their scores is here, but here's what we're really interested in is the average and then the variance, which is a little weird. It's analysis of variance, so it makes sense, but of course, that's the squared standard deviation, but there you go, right? So we got our descriptive stats here. Here's ultimately what we're using to make this comparison across these three groups, between these three groups, rather, to see if there's a difference. All right, so now let's look down at the bottom here in this ANOVA summary table. So this whole thing here is called the ANOVA summary table. Should probably make that its own color too, because that's important. What haven't we used yet? How about a yellow? Okay, so there's our ANOVA summary table. There's a couple things I want you to look at here. We've got our degrees of freedom, right? Our degrees of freedom here, degrees of freedom between and within. Contained here, we have our mean squares between and within. We have our F obtained value here. And then here's our p-value. There's something strange about the p-value in Excel. Let me show you how to fix this. So we want to see this in its decimal form, right? And so, wait a second, I'm still on draw. Let me get rid of this. I don't want to draw anymore. No more drawing. All right. Well, my computer's not cooperating with me today. Forgive me. There we go. All right, so we got this p-value here, this like 1.233, 63 estimated negative 0.6. All right, so we want to change that into just a number. So highlight this cell here underneath p-value, and then go up here where it says, what is this labeled? Under where it says general, switch this to number. Boop, there we go, 0.00. So that's giving us the ratio number for our, based on our F value, right? So here's our p-value here, 0.00. So 0.00 is lower than our alpha level of 0.05. So we know, hey, we found the difference in general between these three groups. So that's called a primary treatment effect for age on creativity. So we're saying there is a relationship between age and creativity, but it's not specific. If it was just two groups, we could look at the two averages and we go, oh, that one's bigger, so that score is bigger than the other. That creativity score is higher than the other group. But we have three groups, so this doesn't really tell us, all the combination of differences that could exist. So what I mean by that is, for example, there could be a difference between the 4-year-olds and the 8-year-olds. There could also be a difference between the 4-year-olds and the 14-year-olds. And then there could also be a difference between the 8-year-olds and the 14-year-olds. So we have these three potential differences here. Then we want to do an analysis to find out exactly where the differences lie. So what we're going to do now, since we've already done the ANOVA, now we can look at these differences between two groups at a time. We can do independent samples t-tests to find out, exactly where these groups differ. So I'm going to go back to data and then to data analysis again. And this time we want to do a t-test. And we're going to do this one, t-test two sample assuming equal variances. That's the one we want. Now in this little window, it gives you, it says variable 1 range, variable 2 range. So we're going to put one of our groups in variable 1, the other group in variable 2, and then we will run the test to see if they're different. All right, so click within that variable 1 range box here, and then it's already highlighted, so that's handy, right? But if you're like me, you want to do it yourself. So we'll highlight group A, the 4-year-olds, then we'll do the same thing now in variable 2 range in this box. Click within that little cell. And then we've got our group B, which are 8-year-olds. There we go. So now they're included there as well. I got the labels selected because I did include those labels. And now I want to show Excel where I want the output to go. So I'm going to select output range here. And I'm just going to go down here below my other table and hit OK. And then we'll look here to see if the 4-year-olds and 8-year-olds differ. Right? So when we're looking here, table for our t-test, we can see the average for the 4-year-olds is 7.6, average for the 8-year-olds is 4.6. And if we go down here to where it says where we have all our p-values, I want to change these into numbers. So these p-values here, right? We're going to go back to where it said, at our home page, and change this from general to numeric or to number. All right, so we have a number there if we're doing a one-tailed test. And if we're doing a two-tailed test, we want to get the number as well. All right, so either way, we have an error rate of 0.00. So we can say, all right, the 4-year-olds and 8-year-olds differ significantly, right? So if we're looking at the averages, 6 and 4.6, okay, so we can say the 4-year-olds had a higher creativity score than the 8-year-olds. Cool, that's interesting, right? All right, now let's find out. Let's go back to data and let's compare our next group. So we go to data and then to data analysis. There we go. And hit OK. The t-test, 2 sample assuming equal variances. Now I'm going to grab, we got the 4-year-olds in for group 1, variable range 1. For variable range 2, now I'm going to compare the 4-year-olds to the 14-year-olds to see if there's a difference there. And make sure labels are checked, go to output range. And now I'm going to go down below the last table we did. We'll do a new table here and we'll hit OK. And now we've got the results comparing the 4-year-olds and 14-year-olds. Now I'm going to change these p-values to numbers again. Oh, it looks like they already did it for us. Well, that's handy. Okay, never mind. It saved it. That's good. Let's see, did it? Let's go to number. There we go. So it just rounded it. Okay. We'll go from general to number so I can see them 0.32, 0.16. Okay, so this number here for these p-values, if there's significance, then it's less than our alpha level of 0.05. So 0.05 is the maximum amount of error that we would accept, which means that even if you reject the null hypothesis, there's still a 5% chance that your results are due to sampling error. So 0.05 comes from that 5%. And these numbers are above 5%, above 0.05. So we would say, yeah, sure, there's a difference between the 4 and 14-year-olds if you'll accept a 16% chance of error, which is just too high for us in the sciences. Anything above 0.05 or 5%, we say that's non-significant. So the 4-year-olds and 14-year-olds did not differ in their creativity scores. Interesting. All right, so we have one last comparison to make between our groups for the ANOVA. And that would be the what am I doing? What are they? 8-year-olds and 14-year-olds. That's what they are. All right, so go to data and data analysis, and we're going to do another 2-tailed test. So 2 samples, assuming equal variance is okay. Now for the variable 1 range, I want to select my 8-year-olds here. So I got my 8-year-olds. Good. For variable 2, I'm going to select the 14-year-olds, and there they are. Perfect. And then for the output, I'm going to put the results right down here. That's a good spot for them, and hit OK. All right, so let's check it out. Let's see what happened. We're comparing our 4-year-olds, or sorry, our 8-year-olds and 14-year-olds. Here we are, right? Here's the average. We got a 4.6 for the 8-year-olds, 7.1 for the 14-year-olds. Seem pretty different, but let's find out for sure. Now we want to change these values in our table from general to numbers again. So right where it says P, right, those are the P values we want to look at. Change that from general to number. And you got one more to do for a 2-tailed test. Well, why not? Let's change that one to number as well. And now we're going to look and see if those are significant. So our p-value here is 0.00 and 0.00, whether you're doing a 1-tailed or a 2-tailed test. We're really just looking at the 1-tailed ones for now. But 0.00, that's predicting a 0% chance of sampling error with these numbers. And that is less than our alpha level of 0.05. So this is telling us we can reject the null hypothesis and we can feel very confident that our results are not due to sampling error. that there is a difference between the 8 and 14-year-olds. So to recap, right, let's look at our t-tests here, these results. Well, let's look at the whole thing. We've got first our ANOVA summary table, which tells us, okay, our p-value is less than 0.05. So in general, there's a relationship between age and creativity. And that means there's a difference amongst our groups. These three different age groups didn't perform the same. And we want to find out where those differences actually are. So we're going to keep going. This test here is called a primary treatment effect. And then we want to go on to do something called the post hoc tests, which in post hoc means like after the fact. So after we have rejected the idea that there's not a relationship between age and creativity, right? We reject that idea, meaning there is a relationship there. Then we want to talk about it, right? Well, what details do we have? Here are the details we have from this data. They come from these t-tests that we ran. So we can see there is a difference between the average of 7.6 and 4.6, which is the 4 and 8-year-olds, right? We see that here, right? So this p-value is less than our alpha level. So we're like, all right, great. So the 4-year-olds had higher creativity than 8-year-olds. Well, what about 4-year-olds and 14-year-olds? Well, these numbers are greater than our alpha level. So there was no difference between the 4-year-olds and 14-year-olds. Okay, that's interesting. So the youngest and oldest age groups in this case performed at the same level. But what about the 8-year-olds and the 14-year-olds? Well, the 8-year-olds had a 4.6 average and 14-year-olds had a 7.1 average. And when you compare those two, it looks like they are significantly different. So we can also say that the creativity scores were higher for the 14-year-olds than they were for the 8-year-olds. So in general, the 8-year-olds did not perform as well as the 4-year-olds and the 14-year-olds, and there was no significant difference between the scores for the 4-year-olds and the 14-year-olds. So you would have to put all that into your write-up. Okay, that was a lot, right? That was probably the most complex thing we do in this class. This is still considered, basic stats. There's so much more to learn about ANOVAs and many different types of ANOVAs. If you want to learn more, it depends on your major, but you take a research methods class or an advanced stats class, and you'll get to learn even more techniques. Okay, I hope that was helpful. And hey, we are just about there, just about done with the class. Just keep the energy levels up. Keep doing the great work you've been doing. Proud of you guys. Good job.